This is lecture number 6 from our online SCM training series. In this lecture, I'll explain you how to perform an exploratory factor analysis using SPSS. Exploratory factor analysis, or EFA, is a widely used statistical technique for explaining the variance within a large dataset using a smaller set of latent variables. It is commonly used to consolidate survey data by revealing the groupings that underlie individual questions. This will be the context of this lecture. The dataset in this example contains hypothetical responses of 200 students on 6 items from a survey on school students. The 6 items asked students to rate their liking for different subjects, including biology, geology, chemistry, algebra, calculus, and statistics. The value of each of these items range from 1, which indicates strong dislike, to 5, which indicates strong like. So to start with EFA, we first import the data into SPSS using the data import option. We go to the file menu, we select open and go to data. Then we go to the folder where we have placed our data. We can see that there are a lot of file type options that are supported by SPSS. In our case, we have saved the data in CSV file. So we go to all files and locate our dataset. We click open. Then we follow the instructions on the text import wizard. And here is our data. So the columns represents the students' like and dislike for different subjects. Next, we try to identify the number of factors to be extracted based on different criteria, such as the eigenvalues, discrete test, and a priori consideration. We go to analyze and select data reduction factors. We select all the variables under the variable option. We go to extraction and select scree plot and eigenvalues over 1, and we go and press OK. We get some results which shows us the total variance explained and the eigenvalues associated with the data and the scree plot. The eigenvalues result indicate that there are 2 factors which has got eigenvalues more than 1. The first factor explains around 46% of variance in the dataset, whereas the second factor explains close to 31% variance in the dataset. Together, the 2 factors explain close to 78% variance. Next, we look at the scree plot. The scree plot indicates that after the 3-factor model, the trend tends to flatten out. So there can be 3 factors in the dataset. Also, a priori consideration about the items indicate that we can group these items broadly into 2 categories: subjects related to maths and subjects related to science. Therefore, we start our exploratory factor analysis with a 2-factor model. It is important to note that several rotation and factoring methods are available when conducting EFA. In this tutorial, we will use PROMAX, which is an oblique rotation method, and recognizes that there is a likely to be some correlation between students' latent subject preferences factor in the real world. Also, we will be using principal axis factoring for extraction of our factor scores because we are interested in identifying the underlying constructs in the dataset. So we go to analyze, we go to data reduction, and we select factors. Under extraction, we go to the number of factors and we select 2. Under the method, extraction method, we select principal axis factoring. We go to the rotation tab and we select PROMAX rotation, which is a oblique rotation method. Then under the options tab, we suppress all the coefficients which are less than 0.3 in the finer factor solution. So the Factor analysis results indicate that there are two factors in the dataset and they together cover around 78% of variance in the dataset. By looking at our factor loadings, we can begin to assess our factor solution. We can see that biology, geology and chemistry all have high factor loadings of around 0.8 on the first factor. Similarly, algebra, calculus and statistics load highly on the second factor. We might call the first factor as science and consider it representative of a student's interest in science subject matter. Similarly, we might consider the second factor as maths and consider it representative of students' interest in maths subject matter. It is important to note that statistics has much lower loading on the second factor compared to calculus and algebra. This suggests that statistics is less related to the concept of maths compared to algebra and calculus. Also, we can see the correlation between our factor scores is 0.76, and recall that our choice of oblique rotation allowed us for recognition of this relationship. There are many other considerations to be made in developing and assessing an EFA, which we have not covered here. The intent with this tutorial was simply to demonstrate the basic execution of EFA in SPSS. So in this lecture we have covered how to perform a basic exploratory factor analysis using EFA. In the next lecture we will explore how to perform a confirmatory factor analysis. If you are looking for online SEM training or support, contact us at admin@pytutors.com.